Okay, simmer down. We're going to get started. Everybody ready? I thought you were presenting. Or was that 11? Oh, you already presented. Okay. You're being. All right. Well, thank you for coming. I'm Michael Maljury. I'm with MarkLogic. I work in the Los Angeles area, and my colleague partner here, Alan Campbell, is from Autoliv. So we're going to be presenting over the next 50 minutes. So let me start with a question. How many of you have been involved with a product recall as, say, a consumer? No? Anybody? Oh, yeah, there you go. How about as a manufacturer? Anybody? You have? Okay. No? Okay. Recalls are not fun, right? It's a lot of hassle, but they're necessary. They prevent disasters. In some cases, disasters may have occurred, unfortunately, but still need things like recalls to fix things, mitigate. What we're here to talk about today is traceability in manufacturing supply chain related to things like recalls. And traceability, there's lots of definitions, but essentially you want to identify and track information about suppliers, parts, subassemblies, assemblies throughout your supply chain and your manufacturing process. And you want to do that for things like reporting, to prevent disasters, to mitigate disasters. And so what we're going to talk about is how we're going to have a case study on traceability and how MarkLogic can help with enterprise traceability, which should be an important enterprise capability for any manufacturing company today. So, by way of agenda, we'll talk about the impact of failures on business, the challenges that companies have with their traceability efforts. We'll spend a little bit of time about the MarkLogic Advantage. Now, you guys have all been here for a couple of days, so we just want to quickly relate the features of MarkLogic that help with traceability efforts. And then I'll turn it over to Alan, and we'll have a real-life traceability case study. We've actually got a demo, and we'll have some time for Q&A, hopefully, at the end. The impact of failure on a business. So let's have some fun with this. You guys can react with oohs or ahs, but what do you think happens if you have a failure? Degraded brand, ooh. You're going to have lost revenue, obviously, if you have failures. Ooh, I heard a ooh there. Greater costs, it's going to increase your costs. You're going to lose trust. That's probably one of the most important impacts that we're going to have on your business. Lose efficiency. This is something I learned from Alan. Sometimes when they have to ship out parts quickly, you pay premium freight. I don't know how much of a cost it is, but it's a cost to the business. You're going to lose opportunity while you're trying to fix things, incur greater risk, possibly have compliance penalties, increase liability. You will lose customer loyalty. And here's one, prison time. I've got a couple examples here where CEOs actually went to prison because of failures. Now, the internet, as we know, is always correct, so I went to it and I put in what are the top 5 failures. So we list this by cost here, but probably the big tragedy is the deaths that have occurred to some of these classic failures. So this is Toyota. You can see 37 deaths, cost of $3.2 billion. One of the key things from a business perspective is the lost disposition between positively disposed versus negatively disposed. So you can see it took a while for them to recover, and here's 2011, but something that's very important to them in terms of loyalty that they had to address. This is the drug industry. See the costs have gone up here, $3.3 billion. Big hit in stock price. Back to the auto industry. Now we're up to $8 billion in costs. And this was related to a scandal. So this is information that wasn't, whether it was intentional or not, I think somebody had to resign over here for it. But it's compliance, reporting. It's about getting the information out and keeping track of it. Back to the drug industry, I mean, this is tragic. And I've seen others, figures that are higher, 55,000 deaths from this Vioxx incident. And again, the cost here, upwards of $9 billion. Merck got hit. And this is one that's more related to what we're going to talk about today. You guys know about the Takata and the airbag problem? $27, $26 billion. And I was searching last night. I think Takata's filed for bankruptcy, or they're in the process of doing that. Okay, and obviously death was involved, which is the major cost. I threw this one in. This is a food issue recall, but the 46 states were affected by this. You had death involved, and here's where the CEO is actually convicted, 28 years along with his brother and a Q8 manager. So real consequences to not having good traceability strategies and for messing things up. So let's look at some of these challenges. If you came to, I presented this morning for entertainment industry, so I'm repurposing a couple of these slides. My opinion, and whether it's right or wrong, is that things are getting more and more complex when it comes to product development, service development, but here we're talking about manufacturing. And this, depending on how old you are, you may recognize this as a classic Cheerios box. This comes from Google Images in the 1950s, I think. The point here is that if you walk down a grocery aisle back then, you maybe had Cheerios, what else? Cornflakes, right? Rice Krispies, few more. And the same thing is true with what today we call running shoes or athletic wear. We call them sneakers. That's PF Flyers. I think you had Keds back then. What do you have today? Just in Cheerios, I was 8 different brands, chocolate, peanut butter, and there are hundreds of these sugar-coated selections that you get. Same thing with athletic wear today. Very big choice. So the point is, bringing this to market, reaching that long-tail consumer involves lots of information, lots of configuration, all the things we know about big data, lots of complexity. Okay? And tracing problems with these manufacturing process and the supply chain gets more and more difficult. Okay, so what are some of the challenges? Well, I just mentioned product complexity. That's one of them. But products like those shoes and what we'll hear about from Alan, it's worldwide operations. You're bringing in materials that are getting transformed in different locations worldwide. And you're using manufacturing systems. If you guys were at Gary Boom's keynote when we kicked this off, he said through mergers and acquisitions, I don't remember the figure, but how many ERP systems? Was it 6 or 10 on average? That's a lot of information to integrate. And so as you make changes along the way, typically you want to bring those changes back into the systems of record. So that's another challenge. You bring in the data into MarkLogic, but we're not always the system of record. You might want to push that information back to some of these systems. So big challenge in traceability. A few more, and again, you'll hear from Alan that this data has to be searchable for decades for compliance and reporting reasons. Lots of companies now are turning to semantics. We're looking at that here in the Autoliv case, just to be able to relate products and components, assemblies, sub-assemblies, to things like suppliers and test equipment. Because when you're trying to figure things out, when you're tracing through to do root cause analysis, it might not just be a one-to-many type relationship that you have in relational databases. You want to find out why things failed. And semantics can help you get to that higher level of abstraction. Obviously, you have to search information, so that's a problem, finding that information. And you've got to have security models in place. With different operations worldwide, the information can't be shared across the entire supply chain, but you need certain information across the supply chain. So, that's the great man there. The MarkLogic Advantage. What does he say there? You cannot solve problems with the same thinking used when you created them. That's the right thing. That's kind of the message we've been trying to get across in MarkLogic. So you have to think of the problem differently. Now, I'm not going to go through this again because I think you've seen this diagram many times. But in the case of manufacturing, what you want to do is bring the information in. If it's coming from 10 different manufacturing systems, you've got to get a look at it. You have to access it as quickly as possible. There might be some harmonization in the case of manufacturing. You have parts that have different identifiers across these systems, but they mean the same thing. They represent the same part or assembly. So there's got to be some harmonization. And then you got to operationalize it, means get it out, in this case, to your traceability folks, your QA folks, so that they can figure out what happened. What's the root cause? And then you'll see in the demo, what's the impact? We're going to do root cause and impact analysis in our demonstration. And I'll quickly put this up. But the features that you've heard about all week is that we use semantics and schema agnostic to bring the data in and relate it. Depending on your application development environment, you could access with different, whether it's REST or Java or Node. And then running and observing things like alerts really help you with running the business, becoming aware of problems that are happening in your supply chain, doing that real-time analytics. I like what David Gorbett says. Let me see if I can get this right. He says in real-time analytics, you're able to analyze many more different dimensions to get real-time feedback and to get situational awareness. I don't know if you use those words, but that's what you want to get situational awareness about an event, in this case a failure, in other cases a customer. You want to focus on this customer or this event, and that means analyzing many, many different dimensions among your data, as opposed to getting lots of data across many years and observing the business, something that happened historically. So MarkLogic can really help with that kind of analytics, and particularly in root cause analysis. And again, the enterprise features are very important because changes are made, you want to do that transactionally. The tiered storage relates to saving the information, and security is also there as well. Okay, I think I'm ready to turn it over to Alan. And you know how to work the buttons.
Okay, thank you, Michael. I think everybody can hear me now. I'm Alan Campbell. Actually, I have an interesting background. I have one of those 15-year degrees, where you go to school, get tired of being poor, go out and get a job, remember why you're going to school, so you go back to school. Been in both computer science and mechanical engineering. My degree is actually mechanical engineering. I want to start out with this is a case study. This is the agenda. I want to introduce Autoliv. How many people here have actually ever heard of Autoliv? Heard of Autoliv before today? Okay. I want to talk a little bit about traceability and what it has meant to us to have it without the integration that MarkLogic has been able to offer us. And actually, this has been a problem we've recognized within our company for many years. In fact, we recognized it long before MarkLogic came along in our relationship. I want to talk about integrating the data across multiple systems in a global manufacturing supply chain. Questions that what we did with MarkLogic, somebody name dropped the MarkLogic name in a teleconference, and I looked them up. And they conducted a little proof of concept with us, and that's really what got us to where we are today. Talk about the importance of leveraging this information, and a little demo. Automotive safety is the field that Autoliv is in, and there are some simple statistics. Every year we directly save over 30,000 lives. What's interesting about this, all these statistics, is that these are related to accidents. In other words, there has to be an accident before these statistics become available. Autoliv is actively working and going into what we refer to as active safety, or electronics, which is accident prevention. Everything from radar systems, braking systems, going to stop the car before you hit the dog, etc. And so I don't know what these statistics would look like if you were to incorporate all the accidents that didn't happen, but they would be very different. A lot of people, Autoliv started out manufacturing seat belts of all things. Now you can see we actually have customers that I'd never heard of before, represented on this slide, but all around the world globally. And if you start to look at the typical automobile, the number of people who have never heard of Autoliv don't have any idea how many different places Autoliv, if you have sat or driven a car, there's very high likelihood that you have been surrounded by some portion of Autoliv products. Everything, I started with the airbags industry, right up around here, okay? And now we're getting into little radar sensors, the things that are embedded in your bumpers and all kinds of places all around the car. Side airbags, side collisions used to be a big deal. A lot of those things now, it's amazing the impact on automotive safety that this has had. In the 20s and 30s, people died in accidents at 20 and 30 mile an hour. And it was simply because they bounced around inside that metal box. Today, those people walk away from head-on collisions at well over 60 mile an hour. Another quick slide. We have a number of employees, as you can see, and this number is actually small now because we've joined in some more acquisitions and some joint ventures. 28 countries. We have a sales office in Australia, but otherwise I think we're active in every continent in the world. Over 100 car brands, 1,300 car models, and again here, 30,000 or more lives per year. Let's talk a little bit about our problem. And this problem originated, I'm familiar with our northern Utah facilities, which is where we manufacture airbags. And that's actually comprised of multiple facilities. We have a facility out there at Promontory, which is like out in the middle of the desert, sits on about 400 acres, where we manufacture a low-grade explosive. Because a lot of times the gas that blows up that airbag is from an explosive. And that material has to be shipped off to other places, and we have what we refer to as an ignition train, because you have a little spark, electrical contact, that tells a very low-grade explosive, or well, actually a high-grade explosive. It's measured in terms of milligrams. In some cases, you have to look at that explosive under the microscope to see it. And that fires off yet another explosive, and there's like 3 different explosives materials in that chain. And finally, the last one, just produces a bunch of gas. Well, everybody's moving towards just-in-time, and I think a lot of people have heard of the Toyota production system. Toyota actually came into Autoliv. We hired them. They came in. We now have what we refer to as the Autoliv production system, or APS. And a whole lot of that in manufacturing is just in time, getting stuff to move quickly. We actually will manufacture things in one facility in the morning, and that afternoon it may be getting consumed in another facility 20 miles away. And by the end of the day or the next day, it could be yet in a third facility where we're going to do the finishing work on that. And so we had a very complex process, as you can imagine, going from manufacturing explosives and chemicals to assembly operations where you're doing like welding and stuff like that. The systems that had been developed over the years to manage and collect that data were very different. Data summarization or reporting was slow, and we actually had a real case. We had a chemical product that we used at one of our facilities. It had the wrong particle size. The behavior of the material or the behavior of an explosive a lot of times is dependent upon the exposure of the material to the spark or the ignition train. And if the particle size is too small, well, it goes off pretty fast compared to a little bit slower. And that was the problem we had. It took us about a week to actually get all the data after we identify the material essentially. We had management. They weren't real happy with that, partly because after a week we had notified one of our customers that we had some product that we had to come get. Luckily it wasn't in any cars yet, but we gave them a list of serial numbers of inflators that we needed to recall because we didn't want them in a car. Well, 3 days later we had to give them a different list. Didn't go over well. And management directed that was something they would not tolerate again. And this is a little bit that describes what that process used to look like. This is the 4 facilities. If you can imagine, and we call them data detectives, or you might call them a DBA. Actually, all these, these are using a popular relational database right now, Oracle. But the schemas in all of them are very different, okay, and we collect different things. And what we would do is, well, a lot of times that would start, you might start down here at this facility where you're actually shipping to your OEM, and you have a hypothesis about a failure that you've just experienced, and you have to call back through this chain to say, hey, what was this thing made out of? Because my theory is that it's something these guys did down here that was the problem. Well, what that involves is going through a bunch of these data detectives. You've got your quality engineers up there at the top. They're doing all the communicating back and forth. And you pass Excel file to facility. They take the stuff out of the Excel file, run another reporting against their system, create another Excel file, pass it on, and it kind of goes on ad nauseum. Well, the whole time this is all occurring, you're still manufacturing product. Okay? Because one of the last things you want to do is shut down someplace. And I don't think that matters no matter what your industry is. You're going to have an allergy to doing that. So it took us about 10 days to get that final list that we were able to give our OEM that said this is the product we need to bring back. Critical issues. We actually manufacture product in Promontory, Utah that goes to France and Tokyo and different places around the world before it's finally incorporated in the finished product. So in some respects, we have to be able to track it all around, and as you can imagine through mergers and acquisitions, the systems that are in place in all these facilities isn't the same. And when I say we recognize the reporting problem, there was a time, I'll say about 5 or 6 years ago, when the management theory was, well, all we have to do is change all these systems to the same system. That wasn't very practical, because you're talking about software that talks to equipment, programmable logic controllers, etc. You've got a whole lot of stuff that you've invested in, and swapping all that stuff out so that you can have a common system is a huge chore. And then on top of that, you actually have to have a big enough system to hold all of it to bring it in, when you're done. The whole problem with data that has to be, preserved. We are required, in some cases, legally, in some cases by our customers, to maintain data for 20, sometimes more years. I don't know if any of you are immune from lawyers. Probably there's a few of you, but at the same time, you have data that you want to have only a short period of time because you're doing an investigation. And any of that data that is held longer than is really needed becomes a liability. So the data that was captured at multiple facilities in different systems before it was shipped to a customer. One of our problems not too long ago, we talked about getting to a neutral format. It wasn't, about 7 years ago, we retired a system that was built on a deck VAX. We were not too long ago, a year or so ago, asked to go pull up data that was about 18 years old. Well, we're out on the equivalent of eBay trying to find another deck that'll actually turn on and run, okay? and the one we found was one model year later, so it didn't run the same OS exactly. And, as you can imagine, it was not fun. And so we want to get to something that's more neutral, like XML and JSON. Security requirements, as you can see, we're a very diverse company. We don't need the people that are dealing with the explosives meddling around in the data on the radar systems. There's just no reason for that. And so as a company, we want to have that security. And the reporting capability. Having data in all these data silos really cripples a company. And I look at this system, we refer to it as containment. When we have an issue, we have to go and find all this product and bring it back, etc. But that's the insurance policy part of this. If you can imagine what it means to your engineering, your product development, to me that's the payback. With the warehouse, we're actually working towards a system where the quality engineer now can run his report, get his data. He can span the data across all of the facilities with which he is concerned. looking at the data from both ends of the horse, because a lot of times you start with a hypothesis. You say, we think this is the issue. You go find that, what you think is that root cause. Then you say, okay, well, if that was the root cause, do I have anything else built out of the same stuff? And so you go back the other way, okay, and you go back and forth. But this actually enables it. We're down to one person, one time, and actual reports that we've written against the same kind of stuff now are down to minutes, where it was taking us weeks with email and everything, to get data together. I'm an Oracle DBA, DB2 DBA. I've been designing databases for many years. And so I'm a strong relational guy, but I fell in love with this when I saw it. And it was because we could bring everything in a schema agnostic way and not have to go through and do all the rip and replace that we had to do every place else, with other methodologies. The REST APIs, I don't know, I guess until they implant us all with chips so that we don't need an interface to the computer, and REST is kind of where it's at, more or less. The goals of the warehouse, we had to have a central long-term neutral format repository for all manufacturing data. Right now I can tell you we're not completely there yet. We still have data silos, sometimes multiple silos within a single facility, but we have some very expensive silos holding 20 years worth of data. We want to drop that down to where we have a couple of years of data in those local facilities, and this will be what I refer to as a final resting place. We have to be able to get value out of our data, and I think I've been to multiple presentations here, MarkLogic World, and that is key to us. To me, I'm a businessman. I don't like just spending money on insurance. Okay, I want some payback, and the ability to query our database, bring in this data from multiple facilities, and allow basically take the shackles off of our engineering teams, of our design teams. That is critical. Data mineable repository, I think, that's fairly obvious. Data life is something else I care about a lot. I have, it's always been preached, but I haven't seen very many facilities or companies actually do it in practice where they actually manage data life. And the first thing you ever do is when you walk into one of your corporate lawyers, is they're going to start telling you you're just a liability if you're not managing your data life. And a lot of companies, and I'm really proud to see MarkLogic and MarkLogic 9. It was a surprise to me. I'm pushed them a little bit further. I want them down to, because I want to have data life management within a document, not just on the document itself, but I think that's doable. Tiered storage. Well, I think by now you can probably all imagine the benefits that we, either are realizing or hope to realize with this project. In this POC, Michael and I were able to put through, I basically challenged Michael, actually probably, you were the number one challenge. We gave him 3 questions. I said, if we put our JSON documents, into this repository, we need to be able to answer 3 questions. If I have a lot of raw material that stopped at one place that we consumed here at this facility, I need to be able to tell every place it ended up by virtue of the product chain. Okay, so if it was a raw material consumed in Tremont, Utah, and it came out the end of the horse at Ogden, Utah to become an airbag in a car, I need to know that, and I need to know who it was shipped to. That's what I refer to as what are the impacted items. I call them the victims. I wasn't very popular when I referred to them as victims. Traceability question 2. I think a lot of companies, manufacturing companies, have this kind of a situation where you have a product at a given point and you suspect something upstream. Okay, that's what this question is all about. If we have something that we say has failed at any given point in our process, and we think it was something that's a subcomponent in there or some activity that took place with respect to that subcomponent, we want to be able to go back and find out what that subcomponent was. Then we have to be able to take that same subcomponent, especially if it's lot-based, okay, and go back the other way. Is there anything else that was impacted? You know, that's that blue bird of happiness flying back down the road there. And what we typically do is if we have any questions or doubts about any of those upstream products, we will try and find something else, you know, that hasn't been tested yet, and we'll do an inspection or a test on that to see if, you know, is it a legitimate problem, or is it just a fluke of a test, or what was it? One of the nice things here, actually, I did challenge Michael to demonstrate alerting, because we have a lot of cases where, you know, you might suspect something, some limit is a problem. And if you're in a process engineer, for instance, and you want to monitor your line, and you want to know, hey, if this particular value off of my line, let's say it's a weld upset or something, if it exceeds a certain value, I want to know about it so I can go see what's going on. Well, we actually challenged him to demonstrate this alerting capability. And one of the nice things about MarkLogic was that he actually evaluated data on ingestion. And if that, you know, triggering criteria was met, we sent an email. And number 3, we ran out of time before we completely finished this one, but it is very doable. You know, he was able to convince me it was not a problem. I don't know of any manufacturing organization. You do work on a piece of equipment, or a piece of equipment experiences a failure and it may not be detected, or the repair may not have gone the way you think it did. And you find out a little bit later. So we wanted to take something that had gone across the piece of equipment and say, okay, for this particular time range, I want to know everything that went across that piece of equipment and where it ended up. And we were able to pretty much complete all of these challenges. These are the things that really helped sell me a lot. We were able to, you know, they convinced me that we could answer these questions fairly straightforward. Our response time for this stuff was minutes. And if you compare that to 7 to 10 days, that's many orders of magnitude of improvement. It took 2 of us, and I had to learn it. Okay, yeah, I actually wrote the queries. Yeah. Michael helped put on the REST interfaces and the front end. And between the 2 of us, we were able to provide this demo, including loading all of the data, in about a 3-week period of time. That made a pretty strong sale to me. And I think that's about the end.
I think there's one more on your next goal. Yeah.
Phase 2 goals. And this is where I'm talking about the payback. I am a businessman. I work on the side as well as at work. And so I care about the payback. And the payback to me is the potential for getting the analytics. I really want our design, our engineers, our quality engineers, I want them unshackled. And a whole lot of that for us depends upon being able to combine the data out of those silos, make it available to them in a quick, expedient manner. There's a lot of things that we do not do today because the process of getting the data together is so cumbersome. We're going to integrate more data sets. I'm working with people around, you know, electronics, France, Japan, China. I'm starting to bring, you know, develop people, and we're embarking on that path now of bringing in the data from all these different silos around the world. So that's pretty much where it ends. Yeah. And I think Michael has a demo.
Yeah, we got a demo. I'm still on here. Good. Well, thank you, Alan, and thank you for those kind words about meeting the challenge. I have equal kudos for Alan, because I never saw anyone pick up server-side JavaScript so quickly and implement some of these complex queries as rapidly as Alan did. So So that was good. We worked well together to put this demo together. So, does that look like a failed part to you? Pull that off the internet, but that's what and I verified that with Alan, I think that's what a failed inflator looks like. So we're going to go through a demonstration here. I'm going to do a little...
I can talk about that.
Oh,
This is the kind of failure you don't want. You see those little holes in that...
oh, sorry, gosh, what did I do? There you go.
The gas is supposed to come out around the periphery there. Well, when you start throwing out pieces of metal, that you don't want to be behind that steering wheel.
Yeah. So we will do this demo with that picture in mind. So what you see here is the POC, the proof of concept that Alan and I put together. Right now, FYI, our professional services team is in the process of bringing this to life and to go into production soon, and then to enhance this, to load much more data, deliver it to Alan's customers, and then to move on to phase 2 of implementing MarkLogic and meeting the requirements. So let me play the role of a traceability expert or a QA person and think about somebody taking that part and dropping it on my desk, right? Okay, what am I going to do about this? I need to do a root cause analysis and an impact analysis. That's essentially my role. So I come to this application and wow, this is all my information from all my manufacturing systems available to me worldwide. You see it in a common search and discovery application that MarkLogic builds for its customers. But that integration has been performed. I have the data in my system now. I could go find it. I could use my expertise. I'm a traceability expert, so I'm going to use my intuition, my other tools, and I'm going to get to the root cause analysis of the system, and being able to get that information in helps me do that. So I won't go through all the features of search and discovery, but one of the things I could do is, let's say I just want to look at parts in the US, I could do that, or I could say, okay, give me everything that's not in the US, all right? And I could do that. So you guys all know how facets work. But hey, I've got that broken, mangled part on my desk. I'm going to flip it over, and I'm going to put in the part number. And I've memorized this because I've done this so many times. Takes me right to that particular inflator. Okay? And thanks to MarkLogic and Alan's query capability, I can click this Made From button. And there I have everything that this part was made from. Now, these labels are a little bit cryptic. That's because we obfuscated this data because it is actual data from Autoliv systems. But you would see more descriptive labels. But, you know, I'm an expert. I know what I'm looking at. Over here on the left, this is that actual part, the TYAJL. That's the failed inflator. So I could start clicking on things. And, you know, I'm doing my investigation. And I could just go right to the source. And again, I'm going to fall back on the fact that this is a POC, so it's not a very pretty display. So I'm fanning out JSON data. So you can get down into things like the subcomponents. In this private data section, I have the variable data, which is the actual tests that this thing ran through. So I see these are some names I made up to obfuscate it, but corrosive permutation and the equipment list, whether or not it passed or failed. So I have the ability to go anywhere in the assemblies and the sub-assemblies for this particular failed part and do my investigation. What I'm going to do is, using again my intuition, I'm going to search for the word warning to see if there's any problem. And look at this. I've got a part or a sub-assembly where there's some warning. So let me go in there, see if I could find what's going on. And I'm starting to feel like I've come into the problem. Yep, okay. So there was a warning message on one of the test equipment. Maybe some parts got through into this inflator and caused a problem. So I'm going to use other tools that I have at my disposal to verify this. I might make a few phone calls, but I'm pretty satisfied that I've done my root cause analysis. And how long has it taken me? A couple of minutes. And if I wasn't talking to you guys, maybe shorter time. But think about it. Alan said 5 to 10 days. Now we're down to a few minutes. Lives are saved by being able to execute this root cause analysis so quickly. So now I got to go the other way. I've got to do my impact analysis. I found the problem. In this case, it's the initiator. It's this explosive device that, instead of blowing out the sides, blew out the top of this thing and caused a problem. So let me go back and just check with my original part. This is the failed inflator. I'm going to look in there and see, yep, GEMJL, that was the part of that initiator. It's one of the subcomponents of that particular inflator. So I've done my root cause analysis. Now I got to do my impact analysis here. Let me go pull up that part. And now I've got this other button, consumed in. Right? So this is going to tell me where throughout my entire supply chain and manufacturing processes is this particular part component consumed. And we've got a different representation here. We don't have a widget, we just have a list. But you can see, that's that part, GEMJL. And this is a list of all the other assemblies, sub-assemblies that have consumed this particular part. So now I take this list, I send it out to the folks that can track this thing down. Where is it? Is it the beginning, which parts are in the beginning of my transformation stage, which might be further down the line, which might be out in the field, which might necessitate a recall. Okay? So again, in a matter of minutes, I've done my root cause analysis, I've done my impact analysis, saved money, saved lives, possibly, and have stopped all those problems that you saw in the beginning of the presentation when things were popping up. Okay. So let me go back here, go back into presentation mode, and we'll recap and have some questions. But in summary, traceability is an integration problem. We've done that. We've taken multiple manufacturing systems. We were able to access that information rapidly. In the POC, Alan and I were able to do that and create, in this case, not semantically, we created a parts hierarchy, but we're looking at semantics. And we were able to ask these complex questions. It's pretty difficult to do that root cause analysis. There's a lot going on behind the scenes. And the bottom line is we enhance traceability for root cause analysis and impact analysis. And now we'll open it up for questions. We got a few minutes. Yes, sir. Sure. Alan, the data comes from relational database.
Can you repeat the question just for the audio too?
Oh, yeah.
That's okay. No worries.
The question is, how was the data modeled to enhance traceability? And Alan's going to field it.
I think every industry probably has their standards for traceability. I look at it as make, model, and serial number. Or imagine it's a washing machine or a sewing machine or an iron or who did you buy it from? Okay, and what was their part number or the make or the model rather, and then what was the identifier for it? Because it could have been lot based if it's a box of Cheerios, or it could have been serialized if it's a. And so we basically just created a simple way to track that. And in our industry, every time we consume a component, we capture that information on that component. So this component has an ID, and if you follow the same simple standard all the way through your process across these systems, the links all work. It basically relies on document linking. Yes, sir.
Just to kind of go further on that, so what about your tier 2 and tier 3 guys? You get the part number, but you don't know who built the subassembly behind it, right?
Yes, we do, because that's part of the standard. So the supplier ID or the make. Okay, so we capture that as we go along. Now, I say that, I can tell you that I've looked at some of our systems around the world and they don't do it like they ought to do it. Okay, but they have the attitude, well, we know it's that part, we only buy from one guy. You might know that today. 5 years from now, I don't know you're going to know that. So there's some weaknesses, and we're able to expose those weaknesses, but we're still able to tie all of that product together. And so I think that what you have to rely on is the standards in your industry, and you have to make sure those underlying systems that you are using, those relational databases, if they adhere to those standards, it should be relatively easy to do.
Would you also be able to track if there was a flood in Thailand, the impact on your production based on the supply chain?
If you were to incorporate that data into that, yes. So any kind of data that you put in there. So, one of the interesting things I've done is I started putting geospatial data in there just because we could and because MarkLogic supports it. Well, one of my questions, then is now because we are a global company, and in many cases we will use stuff from the same supplier in the U.S. that we use in Europe or Asia. Now it gives us the ability to really study our supply chain from just a supplier analysis standpoint.
Yeah, in the demo, you did that manually. Is there any way of automating the process where a failed part would cause an alert, an email, or a mobile alert, and would go through the process of the root cause analysis and the impact analysis automatically, and then would shoot you a report of some kind?
Well, if you can imagine, you'd have to incorporate a bunch of intelligence into that, right?
Right.
I can see where you could do that in the future, and we may go that path. Right now, you can't believe how people's jaws dropped when they were able to say, oh, it was made out of that. I want to know about that. And they could click on it and actually see what lot of initiators it was. Okay, so for Autoliv, that was a big step forward, a huge step forward to be able to do that in just seconds.
So it's a manual process at the moment?
At the moment, yes. But what you're talking about, sure, all those things are, if you can imagine it, yeah, we could probably end up doing it.
Would that also, in the future, perhaps, are you using the same manufacturing execution system in your
Yes.
in your process?
We actually have not replaced this, and we don't anticipate replacing those relational databases on the front line, but we do anticipate that we're going to be providing feedback to them. One of the other things that we're already marching down the road path on is SPC, or Statistical Process Control. And so what you're suggesting, one of the first things you might want to do is take feedback from your statistical process control to, I don't know, do you remember the old, there's a car ad manufactured. It's one of the GM spin-offs where they'd pull the deal and stop the line. Well, if something like that, you could automate those things. You because of REST right now, that's the current. You can get that feedback going both directions. And one of the fears we have in various levels of management in our company is that somebody hits the big red button here that says this is a problem, because we do check. We call it material status. That could bring their line to a halt, and here's Joe sitting on the line. It won't go. He doesn't know why.
Right.
Okay. But
is
from
this
a business,
currently in production? This
it is not yet in production, but that is the direction. That is part of this project. Yes.
Okay. Okay.
Did you have a question? Oh, okay. Yeah.
Mm-hmm.
Yes, absolutely.
Yeah.
Sure. Alerts could be sent on it. Yep.
Yeah, so this is Tim of Campbell. So with SPC, there's also rules that you're probably needing to manage over time, and those rules are changing. What is the process that you use to govern, to make sure that you're keeping up to date with the rules as they change, or as industry changes around you, or compliance changes? How do you manage and govern those changes of the rules themselves?
To be honest with you, I'd probably leave that to our quality team. And what we're anticipating, we'll be using some third-party tools. We don't anticipate at this point doing everything directly in MarkLogic or an application. that's not totally defined yet. We're still working on selecting those analytical tools that we want to adopt and incorporate. So, yes.
So for this POC, was there anything else done other than injecting the raw data to get to where you had, I mean, like having those consumed in and came from queries? I mean, so it's all the data is modeled within your injected raw data, or was there any other rules and models that run on top of that?
No, that if I understand your question properly, that was pretty much all that was done.
Yeah,
was
we
all-
put some
all-
indexes on some of the fields to pull the data. But yeah, it was bringing in the data, writing the queries, and then surfacing it in the application.
Assuming your learning curve was part of this exercise.
It
Alan
was
learned
3
in an
weeks
afternoon.
from installing MarkLogic, pumping in the JSON documents. I actually did the load. I used MLCP. Michael started me on the path down the queries. I completed the queries. He completed the REST endpoints. And I think we did have
We had over 1 million I think
Yeah.
1.3 million documents was ingested on the POC.
from multiple facilities. It was all done in JavaScript. All the queries were done, using the Java API. No, we pull our shipping information from basically an AS400. But no, we capture, this is the as-built BOM. Okay, so our systems are set to validate against, the specified, we call it PLM, or a product lifecycle management system. It's where all that stuff originates, and it has a data flow. Well, what do you mean when you ask that question? Mm-hmm. We haven't got that done yet. Okay, that is yet to be completed, but that is one of the key things that we want to put into place here.
And a small part of the POC was to work with a third-party vendor to use a web connect. And we did demonstrate to Alan and team that vendor could connect and pull information.
Yeah, it was actually, they've been mentioned in some of our sessions, MicroStrategies. And the first thing, to be honest with you, the first thing they wanted me to do is create up tables and set up ODBC for them. I said, no. Okay. They had just barely released their ability to deal with REST services. And so their sales engineer took my no as, okay, well, we'll go use our REST services. And they were actually able to, we set up a REST endpoint for that. And using REST services, MicroStrategies was able to pull in and actually display data. And I can tell you our quality people were pretty happy with what they saw there as well.
Well done. Okay, thank you, everyone. Really appreciate it.